So what we're going to do is we are going to look at that Bohr model and isotope table PDF. So if we look right now, I have it open so we can all see what the worksheet I'm talking about looks like. Hopefully you guys can all find this one too. So number one says when looking at the periodic table, there are a few things we can identify. So let's look at hydrogen. So this is what the element hydrogen looks like on the periodic table. And there's 4 things that we can figure out based off of just that element square that we have right here. So the 4 things that we can figure out are the atomic number, the mass number, the element name, and the element symbol. So can anybody tell me where to put any of those 4 things?
The atomic number goes on the very top.
Perfect.
The element symbol goes on second to top. The mass number is on the very bottom, and the element name is second to the bottom.
Awesome. All right. So now we have our 4 sections of our element symbol, that whole square. We have the 4 sections. So we have the atomic number is that number at the top left corner. I believe on your periodic tables, it's also in the top left corner. If you look, hydrogen has a 1 in the top left. Then we have our element symbol. So for hydrogen, it's H. Then we have our name of our element, hydrogen, and then the mass number, 1.008. So when we're looking at this, there's a few things we're going to figure out just based off of this symbol, this square that we have for this element. So if we're filling out this table below, and this is going to be called an isotope table, and we'll get to that a little bit later, but when we're filling out this table below, let's just fill out the things we can see based off of that square. So the element name, what element do we have above?
Hydrogen.
Hydrogen. So let's just write hydrogen right in here. And then element symbol. What's the element symbol for hydrogen?
H.
H. All right. Atomic number?
It's 1.
It's 1. And the mass number?
1.008.
Perfect. So now the rest of the 4 are going to be a little bit more difficult to figure out, but not too much harder. So what's going to happen is the rounded mass number we're going to need in just a minute. So if I round the mass number, I'm going to round it to a whole number. So if I round 1.008, I want to round that to a whole number. What is my number going to be?
1.
1.
Just a 1. Perfect. Hopefully you guys have learned in math class that anything from 0.5 and up, or 0.5 and greater, I'm sorry, 0.5 and greater, you round up. Anything 0.49 and less, you're going to round down. So we round this one to 1. And then the number of protons. Now yesterday, did it tell you where to find the number of protons? I don't remember it saying exactly where to find the number of protons, but this one's actually going to be pretty easy to figure out because every element is going to tell you how many protons it has if you can see this square right here. So if you can find this square, you'll be able to figure out the number of protons, and the number of protons is always going to be the same as our atomic number. So for hydrogen, how many protons do we have?
1.
1, because our atomic number is 1. So these two, always the same. So the number of protons and the atomic number will always be the same number. Now the next one, the number of neutrons, this is where it gets a little bit more difficult. And it gets more difficult because you have to do some math to figure out the number of neutrons. So if we're looking at our element, the things that we know are the mass number, the atomic number, or the number of protons. But if we know the mass number is going to equal the number of protons plus the number of neutrons. So our mass number is the number of protons and neutrons. Everything that's in our nucleus is all the stuff that has a mass that's large enough to be considered affecting our atom. When we think about it, the masses are all super, super tiny, but in comparison, the protons and neutrons have about the exact same mass, and the electrons have such a small mass in comparison to protons and neutrons that we can just ignore the mass of those electrons. They become negligible, or we can just pretend that they equal 0. So electrons have no mass, but protons and neutrons both have a mass of 1. So if I have 1 proton and 1 neutron, I have a total mass of 2. So if I have 1 proton in my atom of hydrogen and my mass number is 1, how many neutrons am I going to have?
0.
0. Perfect. So it's always going to be the mass number, or a rounded mass number in this case, because we're not going to have a decimal point. We're not going to have 0.008 neutrons. So it's going to be that rounded number is equal to the number of protons plus the number of neutrons. Now the electrons. So this is where we get a little bit tricky again, is because we have to think about protons having a charge. Do you guys remember yesterday it talked about protons having a charge? What was the charge of our protons?
Positively charged or negatively charged?
Protons have a positive charge. Good. So that's right. Protons, positive charge. All right. And neutrons, do you guys remember what neutrons had? What kind of charge?
No charge.
Neutrons had no charge. And then electrons, what did electrons have?
Negative.
Negative charge.
Perfect, negative charge. So if I have hydrogen and it has 1 proton, what's the charge about hydrogen right now? If I have 1 proton and protons have a positive charge, what will be the charge of my hydrogen atom?
Positive 1.
Positive 1. So it would be positive 1. Well, if we're looking at just the periodic table, we don't want to have a charge unless I say that it's supposed to. So unless you're told that it's supposed to have a positive or negative charge, when you look at the periodic table, you don't want to have any charges. So if I have a positive 1 charge because I have 1 proton, how would I make my charge equal to 0? How would I balance out that proton?
You have a negative electron.
Have 1 electron, and that 1 electron has a negative charge, so they'll cancel out and they'll add up to 0. So that's how we're going to solve for our charge. So if we're ever getting a charge, it's equal to the number of protons minus the number of electrons. Since those electrons have a negative charge, we're going to do protons minus electrons should add up to our charge. And neutral atoms, which for right now, that's all the atoms we're going to be talking about. Neutral atoms are going to have no charge, 0 charge. So we want them to add up to 0. So for now, what should our protons and electrons be the same or different? If we look at our protons and electrons, our number of protons should equal the number of electrons because we want no charge. Unless you're told otherwise, the protons and electrons should be equal. Are there any questions on anything we've done so far?
Nope.
All right. So then question 3 says it also helps to know that what the hydrogen atom looks like. To draw the hydrogen atom, we're going to follow the Bohr model or that planetary model that we talked about yesterday in the Ed puzzle. So what 3 things did it say we needed to include in our Bohr model? Do you guys remember what 3 things we had to include?
The nucleus of the atom.
The nucleus of the atom. What goes in that nucleus?
Protons and neutrons.
So the nucleus, which consists of protons and neutrons. And there's one more thing. So we have protons, neutrons, and
Electrons.
the electrons. So we need to draw our protons and neutrons in the nucleus, and we need to draw those electrons in those rings or orbitals, as we're going to call them, around that orbit or go around the nucleus. So when we're drawing this, we're just going to use this table to pull out all the information we need. So I'm just going to rewrite over here that I want my protons, my neutrons, and my electrons. And we wrote that we have 1 proton, 0 neutrons, and 1 electron for hydrogen. So I'm going to use that information to draw my Bohr model for hydrogen. The first thing we're going to do is we're always going to take our 2 things that go inside the nucleus. We're going to draw that nucleus first. So I'm going to put protons and neutrons in a circle in the nucleus. So this is my nucleus. And I'm going to label that I have 1 proton and I have 0 neutrons. Now, I mean, we could go farther if you really wanted to and draw it where you draw positive charges and zeros to count them as protons and neutrons. But as we get further and further, we're going to draw Bohr models all the way up to element 18, which has 22 neutrons. So I don't know if you want to draw 40 pluses and zeros in your little nucleus. So instead, if we just write this with 1 proton and 0 neutrons, that shows me you know what our nucleus is supposed to look like. Now, the next thing we can draw is our orbitals. So the orbitals are going to be our rings that go around the nucleus. So I'm going to draw 1 ring that goes around my nucleus. And how many electrons am I going to put on that ring?
1.
1 electron. My electron, I'm just going to use as a dot to represent my 1 electron going around the nucleus. And that's our whole Bohr model. Not too hard, right? Hopefully. Or is it terrible? I'm going to say that it's not terrible because no one's answering either way. So there are 8 problems for this table to fill out based off of the periodic table. And then there are Bohr models that you should be drawing for all 8 of these problems. Couple things I want to talk about from the periodic table before I let you guys work on your own, or if you want to ask questions, is if we look as we go across the periodic table, those rows are called periods, and those periods are going to tell us how many orbitals or how many rings we have around the nucleus. So if we're in this first period or this first row, that means we're going to have 1 ring or 1 orbital going around the nucleus. If we're in that second row or that second period, that means we're going to have 2 orbitals going around the nucleus. And that's just going to keep going as when you go to the third row, if you go to the fourth, the fifth, however many rows that you have, that's how many orbitals or rings you're going to put on around your nucleus. Now the next thing, every time you get to a new row, so if we fill out 2 electrons, that's our first orbital. Every time you start a new row, you need to add those electrons to the second orbital. So if I get to lithium, my third one down here, I need to put my third electron on my second orbital. So if I'm drawing my orbital for lithium, I have my nucleus with my protons and neutrons. I draw my first orbital where I put my 1, 2 electrons on my first orbital. When I get to lithium on the second row, I'm going to add a new ring around my nucleus to put my third electron. Everybody okay with that? Or does anybody have any questions?
So there's only like 2 electrons on each ring.
So that's for the first row only. So great
Okay.
question. So if we look, that first row only has 2 elements. So we can only put 2 electrons on that first row. The second row has 1, 2, 3, 4, 5, 6, 7, 8. So we can put 8 electrons on that second ring. So this whole row counts together. Any other questions?
Can you do carbon as another example?
Carbon as another example. Perfect. Let's go through it. I'm going to erase all this real quick. All right. All right. So let's just pull out, let's get all the information for carbon. So let's look at carbon. So let's just go with protons, neutrons, and electrons here. So protons, neutrons, and electrons for carbon. So how many protons does carbon have?
6.
6. Perfect. We got that from our atomic number right here. How many neutrons does carbon have?
6.
6. This is also perfect because if we look, carbon has 12.001 for its mass number. And remember, our mass number equals number of protons plus number of neutrons. So if our mass number, when we round it, is 12, so 12 equals 6 plus the number of neutrons. Our number of neutrons will also equal 6. And then how many electrons are we going to have for carbon?
6.
6. Perfect, because right now, for this worksheet, we want all of our protons and electrons to cancel out. We don't want to charge. So these two for this worksheet should be the same. So now that we know that information, the first thing we draw when we draw our Bohr model is going to be what?
The nucleus.
The nucleus. So we're going to draw our nucleus, and we're going to put what 2 things inside the nucleus?
Number of protons and neutrons.
Protons and neutrons. Perfect. So we'll put our 6 protons and 6 neutrons. And now it's time for those electrons. So if we look, the first 2 electrons come from hydrogen and helium. So we put the first 2 electrons on that first orbital that goes around the nucleus. So we're just going to put 2 electrons. Right now, it really doesn't matter where you put them, just as long as they both land on that first ring or that first orbital. So that first orbital is gone because we filled out both of those electrons. We now go to the second orbital. So we have to create a new orbital or a new ring for the next row. So now we go 1, 2, 3, 4 electrons. And those 4 electrons go around the second orbital, or the second ring. So now if we look, we have 6 protons there, we have 6 neutrons there, and then if we count, we have 1, 2, 3, 4, 5, 6 total electrons. So we have our 6 protons, 6 neutrons, and 6 electrons drawn on our Bohr model for carbon. Anybody have any questions about that? Or do you guys think you understand it?